We're looking at section 12.3, geometric series. So we're going to derive the formula for the sum of a finite geometric series when the common ratio is not 1, and then use the formula to solve problems. So a series is the expression formed by adding the terms of a sequence. If the sequence is geometric and has a finite number of terms, it's called a finite geometric series. So let's work with our Explore here. We're going to start with a rectangular sheet of paper and assume the sheet has an area of 1 square unit. Let's say you cut the sheet in half and lay down one of the half pieces. Then cut the remaining piece in half and lay down one of the quarter pieces as if rebuilding the original sheet of paper. Continue the process at each stage, cut the remaining piece in half and lay down one of the two pieces as if rebuilding the original sheet of paper. So we're going to show this two ways. First as the sum of the pieces, and also as a difference from the whole sheet, subtracting off the pieces that are remaining. So with our stage 1, we had our whole sheet and we cut it in half. So the area we put down was 1/2 of the original. We think about it as a difference. We take 1 minus the piece that we're missing, so minus 1/2 to also get us 1/2. In stage 2, we added in the quarter piece, so we'll have 1/2 plus 1/4 to get 3/4. And then we're also then just missing a quarter. So a whole 1 minus the quarter gets us 3/4 or 3/4. In stage 3, we add the half, we add in a quarter, we add in 1/2 of a quarter, which is 1/8, and we end up with 7/8. As a difference, we're missing just 1/8 of our whole, so 1 minus 1/8 is 7/8. And then stage 4, we had the half, we had the quarter, we had the 1/8, and then we added in a 1/16 to get 15/16. As a difference, we're just missing a 1/16, so we've got 15/16 of the whole. So if we want to write the sequence formed by the areas of the individual pieces that are laid down, we had 1/2, 1/4, 1/8, 1/16, and we could have gone on from there. So that's a geometric sequence with a common ratio of 1/2 each time we were dividing by half. In the table from step B, you wrote 4 related finite geometric series: 1/2, 1/2 plus 1/4, 1/2 plus 1/4 plus 1/8, so on. And then we found the one way we found the sum of each series was simply to add the terms. So described the other way, we subtracted the last term from of the series from 1. A lot easier method of doing it. So if the process of cutting the remaining piece of paper and laying down one of the two pieces is continued, you obtain the finite geometric series 1/2 plus 1/4 plus everything in the between plus 1/2 to the nth, whatever that final stage we chose was. So if we use our answer to the previous question, oh boy, what did we do? There we go. If we subtract the last term of the series from 1, we'll do the same thing here. We'll take 1 minus the last term of the series, so that's 1/2 to the n power. So let's use this to derive the formula. So to find the general formula for the sum of a finite geometric series with n terms, begin by writing the series as a function. So s of n is equal to a, the original term, plus a times r, the common ratio, plus ar squared, plus so on and so forth, until we get a times r to the n minus 1. So let's say we multiply everything times r. We take our function times r. So we have a times r, plus ar squared, plus ar cubed, so on and so forth, plus a times r to the n power. So let's say we subtract these, s of n minus r of s of n. We end up with, where am I at? A plus, we can see all these terms are going to cancel out, so 0 plus 0 plus 0 plus 0, and then minus a times r to the n. So if we simplify that expression, we look at only the pieces that we have a minus a times r to the n. So if we can factor out an s of n. We have 1 minus r. We can factor out an a over here. We have 1 minus r to the n. Solving for s of n, we divide both sides by 1 minus r. We have that 1 minus r to the n in our numerator over 1 minus r. That's being multiplied by a. So that is going to be our formula that we'll use for our geometric series. So we can double check that that formula works, but it will. What are the restrictions on the value of r? R can't be 1. If we look back at this formula, problem areas would be in the denominator. So if we tried to set 1 minus r equal to 0, we'll end up with 1 equals r. So r can't be 1. We'll have a domain error from that denominator in the function. So that's our formula. S of n is equal to a, the original term, 1 minus r to the n. So our common ratio to the n power, number of terms we have, over 1 minus r. So recall that you learned how to find a and r for a geometric sequence, and the technique is no different for a series. A is the value of the first term, r is the ratio of any two successive terms. To find n, you can simply count the terms if they are listed. So for instance, the finite geometric series 3 plus 6 plus 12 plus 24 plus 48. You see a is 3, the common ratio is 2, and the number of terms is 5. If some of the terms have been replaced by an ellipsis, we obviously can't count the terms. One way to deal with this situation is to generate the missing terms by using the common ratio. I think normally that's the easiest thing to do as long as there aren't too many terms. You can just find all the missing terms and then count them up. Another way to do it is to recognize that the nth term is a times r to the n minus 1. So you can substitute that in. So take your value and your common ratio, set it equal to the last term, use that to solve for n. So that's one method you could do it. Again, I think it's normally easier to just find the missing values as long as there aren't too many terms. If we wanted to find the sum of the geometric series, we want to find the values of a, r, and n. So a is the initial term 5, r is the common ratio, which is 3, count the number of terms, which is 6. Plug those values into the formula. And then this is mostly just all calculator work, plugging stuff in and finding the values. So we've got another function here. We want to find the values of a, r, and n. So a is the initial term, 1/4. To find r, we'll divide 1/8 divided by 1/4 to get us our common ratio of 1/2. So here, we're finding out how many terms there are. Again, you can work through this process. I think it's normally easier to just find the missing terms. You'll find out through this that n is equal to 8. So once we have those values, we can plug them in. So s of 8 is equal to 1/4 times 1 minus the common ratio, 1/2 to the 8th power, over 1 minus 1/2. So 1/2 to the 8th is 256. So 1 over 256. Doing that subtraction, we'll get 255 over 256. Divide that in half, we get 255 over 128. Multiply that by 1/4, you end up with 255 over 512. So again, most of this is just going to be plugging stuff into your calculator. So here we have a is equal to 1, the common ratio. We have -2 over 1, so our common ratio is -2. Number of terms in our series is 6. So we've got 6 terms. The function says we take our a value 1 times 1 minus the common ratio to the n power. Now this is important since we have that -2. Remember to put parentheses around your negative before you raise it to your power. And then over 1 minus -2. Come back in the next video to see the conclusion of this problem and finish up this lesson.